We trust software with pretty much everything these days. Our money, our secrets, even our lives. But what happens when that trust is broken? So today, we're going to dive into the ethical blueprints that are designed to prevent exactly that, digital disasters. And I mean that literally. We're not just talking about a website crashing or losing a file. When the code that runs, well, our world has a bug, the results can be absolutely catastrophic. So let's get into a really chilling real-world example, a medical radiation accelerator. Now, this was a machine built to heal, right? Its whole purpose was to target and destroy cancerous tumors with incredible precision. But, and this is the scary part, a hidden software bug flipped the script. It turned this healer into a weapon, delivering massive, fatal overdoses of radiation. Yeah, that's the question, isn't it? The one that keeps engineers and developers up at night. And look, this isn't just about one person making one typo. It's way more complex than that. It's a total breakdown of process, of oversight, and, yeah, of ethics. And figuring out the answer is crucial to making sure it never, ever happens again. So the big question is, how do we prevent something like this from ever happening again? Well, that's where professional organizations come in. They've put together what are called codes of ethics. And you can think of these as the rule books for building tech the right way. And listen, the key word here really is practical. This isn't some dusty philosophical textbook we're talking about. Nope. A code of ethics is a hands-on guide, almost like a checklist for making those tough calls that impact real people in the real world. So in the tech world, there are really two main players that set the standards here. On one side, you've got the IEEE. That's the Institute of Electrical and Electronics Engineers. Think of them as the folks representing the engineers who build the heavy-duty hardware and critical systems. And on the other side, you've got the ACM, the Association for Computing Machinery. They're all about computing, the professionals working with software, data, and all that good stuff. All right, let's start with the IEEE. The best way to think about their code of ethics, it's like the structural blueprint for a skyscraper. It has to be rigid, super precise, and its number one goal, above all else, is making sure that thing does not fall down. It's all about public safety. And this isn't some new idea either. This blueprint has a really long history, with roots going all the way back to early 20th century electrical engineering. But here's the cool part. It hasn't just sat on a shelf. It's evolved. It's been updated to tackle today's biggest challenges, things like artificial intelligence, and it even bakes in this idea of ethical design right from the get-go. So what's this whole code built on? Well, it's surprisingly simple. It all comes down to just 10 core rules. They call them canons, and trust me, they are crystal clear and totally non-negotiable. All right, let's check out the heavy hitters here. Canon 1 is the big one, the absolute foundation. Public safety, health, and welfare come first, period. End of story. Then you have Canon 6, which is all about competence. Basically, don't build stuff you're not qualified to build. Makes sense, right? And Canon 9 is just a straight-up command, do no harm. So for the IEEE, it really boils down to this. Safety and competence are everything. Okay, so now let's switch gears and look at the ACM. If the IEEE code is that rigid blueprint, the ACM code is more like a moral compass. It's not just about don't do this. It's designed to help tech pros navigate those really complex, often gray areas of how software actually impacts society. And the way the ACM is structured is actually fascinating. It's not just a list of rules. It's really a framework for thinking ethically. It starts with the big picture, the why. These are the general principles. And then it drills down into the how, the specific professional responsibilities you have to implement them. It's really meant to be an educational tool. And right away, you can see the difference in focus, can't you? The principles here are things like contributing to society, respecting privacy, and designing secure systems. The ACM is really focused on things like data, security, and the way software impacts us as individuals in our daily lives. Okay, so let's put these two side by side for a second, just to make it super clear. You've got the IEEE, which is all about critical engineering systems, medical devices, airplanes, and it uses 10 rock-solid rules. Then you have the ACM, focused on computing, data, and privacy, using this layered set of principles to guide your thinking. One is a blueprint, the other a compass. And here's the thing, you absolutely need both. All right, so now that we have our ethical toolkits, let's go back. Let's return to that tragic medical accelerator case, because now we can really dig in and analyze what went wrong, but using these two very different lenses. So from the IEEE perspective, this is just a clear-cut disaster.
Canon 1 public safety was catastrophically violated. I mean, there's no debate there. It was also a massive failure of technical competence, right? The fact that there were no hardware backups, that's a huge engineering oversight. But when you look at it through the ACM lens, you see a whole other layer. The ACM code reveals a failure in system design. The user interface was so clunky and confusing that it was practically inviting errors. And it also points the finger at a management failure. The operators, the people using the machine every day, they had raised concerns, but they were totally ignored. So you see, it wasn't just bad code, it was a bad process.
So what's the big takeaway here? What does this all mean for the technology we're building right now and in the future? Well, the most important thing to understand is that these two codes, they're not competing with each other. They're two halves of the same whole. They're both absolutely essential for building an ethical digital future.
You've got to have that unyielding, safety-first rigor of the IEEE, especially when you're building systems that can cause real physical harm. But you also need the societal nuance of the ACM to handle tricky issues like data privacy, user experience, and fairness. Seriously, one without the other is just an incomplete picture. And this brings us to the most practical, actionable advice. Ethics can't be something you bolt on at the end. The experts are crystal clear on this. These principles have to be woven into the entire software development lifecycle. That means from the very first brainstorming session all the way to the final release and beyond. And that, of course, leaves us with a huge, critical question for the future. As AI gets more and more powerful, more autonomous, how do we make sure our ethics can keep up? How do we literally build these ethical blueprints directly into a machine's logic? I mean, how do you teach a machine the difference between right and wrong? That, right there, is the challenge for the next generation of builders.